Hello, me again. I am Yongzhi Huang. This time I'm going to talk about the Lili. What does Lili mean? It means the liquid quality monitoring based on the light signals. I think everyone has drunk wine probably. You know, fermentation and the aging are two key steps in the industrial wine production. These two processes require the wine to be bottled for a long time. Some of them may need to preserve for more than 10 years. We may not notice that during this period, numerous microorganisms begin to grow and multiply. Even those harmful pathogenic microorganisms, these may cause serious food safety issue in the alcoholic beverage. Well, even the manufacturer has safety testing, but those safety testing in wineries involves two main sets of the product tests. One is the pH measurement, and another is the microbial cultures. However, such testing is time-consuming and cumbersome, and it also has a high probability of inspections missed. These methods can detect the deterioration only when the barrels are opened and cannot detect the real-time deterioration during the production process. As a result, for a long time, late detection of the deteriorating liquids has led to a serious economic loss in the manufacturing. So, can we find an alternative to the traditional microbial cultivation? And it is possible to achieve real-time wine quality measurements. By the way, can they be made with common instrumentation? In fact, they are opportunities. Researchers have found that deterioration can change the liquid properties, especially at the surface. Deterioration of a liquid will change its surface tension, and the microorganism inside will further cause a subtle change in the absorbed spectrum. So in this paper, we propose a lightweight system named Lili to measure the change of surface tension and absorption spectrum. It can monitor the wine quality with light signal, and that can be installed in the brewing equipment after the encapsulation. Instead of using the cameras or other expensive components, Lili only utilized the vibration motor and LED and profile diodes. Lili is based on reflection because when the liquid surface vibrates, it will produce the moving calibrate waves. These calibrate waves produce reflections. As the wavelengths become shorter, the frequencies of reflection will increase. We can also see it in the simulation below. Therefore, we can find the law of calibrate wavelength change from the reflected light signal spectrum. Okay, now is the absorption spectrum. The use of absorption spectrum is very common, so I won't go into the details here. In summary, the changes in the absorption spectrum can be used to detect many subtle composition changes. However, these spectrum changes is really tiny. Well, you can see on the left, we also have the experiments for the feasibility analysis. We test it in a small cup. We can get some coarse-grained data as can be seen from the figure above on the right. The surface tension is negatively correlated with the peak frequencies. That is mean the reflection light signal have the relationship with the capillary wavelength. And in the frequencies domain, we can also find that the absorption spectrum in some frequency bands has appeared large differences. This is a signal shows the composition has been changed. We can see the figures on the left show that the surface tension of the contaminated samples fluctuated over time. And we can also see on the right that the changes in the absorption spectrums of the contaminated wine. To qualify the deterioration, we proposed a new discrimination methods based on the feature path deviation degree that take advantage of the temporary variations of the feature. And we established two measurement tables containing the surface tensions and the absorption spectrum. The contamination time was divided into a 12 hours period, labeled from 1 to 6. The microorganisms contents were divided into the 4 levels. And finally, by comparing the same time point with the standard path, we calculated the feature path deviation degrees to determine the wine deterioration degree from the measurement tables. After completing the feasibility study, I will now explain how to meet the challenges in practical use. Firstly, some containers may allow ambient light radiations to reach the protodiol. Ceiling light and sunlight will let the spectrum slightly fluctuated. So, before detection, Lili will turn off the LEDs and calculate the ambient light's average amplitude and frequencies curve. After the LED enters into the test mode, it subtracts the ambient light's amplitude and frequencies curves from the signal. On the other hand, the steps and the collision of the people near the container will cause the wine to slosh, which will affect the measurements. We calculate the average amplitude A and the amplitude sums S by setting the threshold for determining whether the sloshing interference occurred. By suspending the measurement for 30 seconds, we can avoid this interference. When deployed in proving equipment to generate the capillary wave, the motor will produce a considerable noise to the LED and the protodiol demodulation modules. However, traditional filters are not suitable for this complex frequency noise cancellation. Fortunately, this is addictive noise. This shows that when the capillary wave changes, as long as we take the data with a long enough time to analyze the signals before and after the capillary wave changes. The spectrum component with great difference is the spectrum offset. The results show that there is more than one characteristic point, which is the result of reflected light having different multipaths. Because of time constraints, we can see in the paper how we calculate the frequency differences between these corresponding characteristics. How to expand the dimension of the cross-grain absorption spectrum? We found that as the current increased, the full width as head maximum of the LED spectrum will expanded. In this way, we can adjust the LEDs with different bandwidths by the current. Through the different combination, we can get different central frequencies bandwidth, and these different central frequencies bandwidth can synthesize. More details are presented in the paper. Okay, and next let's see the Lili's demo.
We have 10-liter uncontaminated red wine in the brewing vessel to simulate the aging process. We deployed Lili on the vessel, which is powered by 5-voltage battery. We turn on the switch and use MATLAB on the computer to receive signals in real time. We first recorded the surface tension and absorption spectra for 72 hours. It can be seen that they remain stable. Then we put a moldy grape into vessel to simulate the contamination of red wine during aging. As we can see, the surface tension and absorption spectra are significantly different from those of the uncontaminated condition.
We found that the surface tension error is under 1.16 and the absorption spectrum is under 3.04%. The results also show that the container value and the container material almost didn't affect the accuracy. From the experiment result, we can see the accuracy of identifying is really high, at 97.5%, and the mean absolute error percentage in identifying is only 1.77%. As a summary, Lili is an innovative system in which we overcome many challenges to turn cross-grain signals back into the fine-grain signals. This allows Lili to be used to monitor wine production in real time. It can detect the spoilage in real time and reduce the health risk and the loss caused by unnecessary spoilage. And that is all. Thank you for listening.